Hello and welcome to the Side One YouTube channel. My name is Ray, and in this video, part 14 of the R2D2 build, I'm going to look at the dome drive motor assembly, and I'm also going to look at the wiring loom that I've done so far. So off camera I did create a wiring loom for the 10 or potentially 10 servos in the body of the robot. But before we get to that, let's assemble all of this. So in the description I will have links for all of this. All the files are available from the Mr. Badley Patron. If you join his Patron, you can download these files. Alright, so this piece here is designed to mount on the back left hand side of R2D2. If you mirror it, you could mount it on the back right hand side, but I'm doing the back left hand because that was the easier one to do. While I was printing this, I was having some extrusion issues with my printer, and so you'll see some marks. If I get this up close to the camera, you'll see some marks here where it's under extruded in a few places. It hasn't really affected the strength of it to any great deal. It appears reasonably rigid, and it's not something that's visible from the outside of the robot. I have since had that diagnosed, and it turned out that there was something wrong with either or the hot end or the extruder. But Anycubic, the maker of my printer, have actually supplied those parts. They've been fitted, and the prints coming out are much better now. So let's start with this piece and this motor. Now, I've had this motor for a little while. I bought this from eBay. You can also get them from AliExpress or Amazon. It's a 919D series. It was designed for drills, essentially. 4.5 to 15 volt DC, so it'll work quite nicely on our 12 volt supply that we'll be running our main motors on. So this mounts in here. Do it the right way up, like so. Now I have got some wire on here. This is from memory 1.5mm speaker wire with a sheath over it, and it's just long enough to get down to my control board, which I've still got to design and build. We'll be using M3 screws with M3 nuts, hex nuts. And down here there's a hole and provision for a nut. That was the easy bit done. Next we have this gear drive. Now this will engage to a ring gear that is attached to the Lazy Susan, and will drive that ring gear, turning the dome, so part of the gear dome. We drop a square nut down through the hole. This is an M4 screw. And it's 10mm long. Now you could probably get away with 8mm. I don't have 8mm, I've only got 6 and 10. So this one's a little bit too long, but it doesn't interfere, so it will work nicely. So we do the screw up until it just starts to poke out through the hole, and then wind it back so that it's clear. And it would be good if that cleared up, but it was enough to see. Now on the motor there is a flat, and you can see I've had these done up before on there. I'm just going to push that on. It'll go on until that flat part in there sits on this flat edge here. once it's on, we just do the screw up nice and tight. We don't need to over tighten it, just snug it up. If you over tighten it, you will break it. I may have had some under extrusion happening in here as well, but it's not too bad. It'll work. Alright, so the next part, and this is where I still haven't fully made my mind up, but there are two types of these slip rings available. This is a 12 wire and this one is a 6 wire. Now both will do the job. All we really need to go through the slip ring is power and data communications, and we could probably get away with just 2 wires for the data, particularly if we use something like the I2C protocol. If we use the 12, we can actually double up our wires so we can get more current through. These aren't rated at a very high current. I think it's around about 12 amps, but I can't see 12 amps getting through there. I think the part number is, just 12A and someone's misinterpreted. Although this one's 6 wires and it says 12.05 amps. So it's possible we can get quite a bit of ampage through it. So for now, I'm just going to put the 12 wire in. If I change my mind, I can always pull it out and put it back in, the other one in. It's not that hard to change over. The slip ring just drops down through like so, and then we can run the wires up through this middle hole. And that stops it tangling on anything as well. Alright, now to keep that slip ring in place and to make sure it doesn't fall out, we have this piece. Now this mounts so that there's a slope up, and we have this piece which will mount this way. It has 2 square nuts and then screws come up from underneath. So get this one in first, feed the wires up through the middle, and put our screw up from underneath. This is an M4 12mm long countersunk screw, and that locks in place. Flip it over, drop our nut in here, and repeat with another 12mm long M4 screw. Once these 2 screws are done up reasonably firm, that locks the slip ring in place. It's not moving on the bottom side, but the top side can still rotate. Okay. Now, when I was looking to fit the wiring loom into the body of R2, I needed some way of holding the wire up against the side, because I'm still toying with the idea of an automated lift mechanism for the center wheel. So I need to make sure any wiring I have in there stays clear of that mechanism. So doing a search on MakerWorld. Was it MakerWorld? Maker Online. So I found this one in Maker Online, which is the Anycubic version of MakerWorld, which is the I've forgotten the name of the company that makes them now, the X1 Carbon printer series of printers. This is actually scalable, so I have scaled it a little bit. I've actually scaled it down, and there's enough room in here to hold my wiring loom for the servos, plus wires for the legs, and another wiring loom when I get to it for the lights and sound that will be going into the robot body, and potentially any other wires I need to put in. To mount these, I've just used the standard type servo screws that come with standard size servos. And wherever I've mounted one of those, I've drilled a 1mm hole just as a pilot hole for it to go through. And that's worked quite well. So let's have a look at inside the robot. I'm just going to move the camera. So what we have here is the inside of my R2D2, and you can see here the wiring loom. Just take these two hubs out for the moment. I will be mounting those in there today. So I've put a cable clip over here, another one over here into this out piece here, where I think it was ring 2 was bolted together. This is actually fairly thick, this piece on R2, and I've also mounted 2 clips over on the other side into that same area where it's nice and thick. And in here I've got a clip mount, so where it's been welded in here, I've put a clip in through the side, so it's not the screw won't come out and show everything off. So these 2 wires will be for the gripper arm when it goes on, and these 2 will be for the data arm when it goes in. I've also got provision down here for the extra servo should I put that in for the charge port, which is up here. And then down over here I've got the connections for the 2 servos, the data port and for the bread pan door on this side. So I may put some little cable ties on just to keep this nice and tidy as I go further along. I've also got a connection here and here for the utility arms. So that's the wiring loom I've done, and you can, if you look inside here, you can see there's still plenty of room. Let me grab my screwdriver. There's still lots of room in there for more wires to go in. So this one on its side, and you can see there's heaps of room in there. That's just to keep the wires tidy and away from all the works. Okay, so there is a part, and I'll link it in the description. If you've got a very large form printer like a Creality CR10S5, which is a 500 by 500 by 500 build volume printer, you can actually build all of these major parts as 3 rings and in one piece. And when you do that, you don't have this joiner here, just outside the camera range, of course. Just here is a joiner, and it gets in the way of this piece. So I've had to literally cut the piece into 3 pieces. One part's been discarded. One piece gets mounted up here, and it holds nuts in place for this to mount on, and the other one mounts up in here. You can actually see on the other side, and I might see if I can tilt this a little bit. This little piece here is also, and of course this main mount here, are also used for potentially one of these dome drives when printed as a mirror version. So this will mount up like so, and screws will come in, and because those nuts are very hard to get at, that's what this frame was for, to hold those nuts as a captive nut. So I'm going to be using these 12 these screws, and I think they're 12, they might be 15. 14 M4 by 14 mil long countersunk screws. I'm going to use those to mount this up. So I'm going to start with the bottom screw on towards the back. And right in under here where it's very hard to get at because there is part of the hub for the wheel mount is in the way. So that's all done up. Just get these wires through here a little bit further and out of the way. Alright, so that'll go up through the middle to run the dome. And we've got all those in. Now before I put these pieces on, we need to really put nuts and bolts through here and here to make sure that this mount can't move. It does carry a lot of weight. In fact, between the two of them, they carry the whole robot weight. So these screws are a little bit on the long side, but I haven't got anything any shorter. They're 40 mil long. I'm thinking 30 to 35 mil would have been better. I just don't have any that size because they are 12 mil too long. So yeah, 30 would probably be a better size. So these are just flat Phillips screws. So between locking down at the top here and locking down here, that hub is not moving inside anymore and should improve stability on the robot quite a lot. Okay, so the next part that we need to look at are these covers. Now these covers, I've actually painted and assembled this. So these are printed as multiple parts. You have the main, I think they call it a vent, body vent, and then these four pieces here. I started out by masking off all of the inside. I painted the outside silver. Then once that dried, I masked off all of the silver and painted the inside blue. I also painted these strips silver and then I glued them in. They're not structural, it's only purely decorative, so the CA glue will work okay for that job, and I did both of them at the same time. On the back side, we have a slot here that we can drop in a square nut and push that down into place. And there's another one at the top here, out of view, so square nut in through there, and another one at the top here, and I'll use an Allen key to just poke that all the way down. There it is. So it goes through that hole, and then we can mount that on the side. Before I do that, get my screw, which is 14 mil long, M4 countersunk. That pokes through that hole, will stick out the outside, and then we can just put our part in place and screw it in. Okay, that's that one in place. Let's repeat. Drop a square nut in through there. Push it down. square nut in through the top and push it down. $12mm long M4, 12, 14mm M4. Okay, so that has both the vent covers on. Those are the bolts to bolt the legs on with, or the nuts to bolt the legs on. And these are the nuts and screws in here. Let me find the long bolts to go through. These are all of the bolts. So these are the same screws I used last time. They're a countersunk 60mm long screw, M4. We take our hub, make sure that the index part is facing down. I'm going to put that one through that hole, push it in, and that goes into here, and we pull it all the way to the forward position. Open up my bag of nuts and washers. So my big mudguard washer. Now it's a little bit too big for the M4, but I'll put an M4 washer behind that, and then my nylock nut so it doesn't come loose. Now it is tempting to use a impact driver or a power drill to do those nuts up. If they're just ordinary nuts, that's fine, but with those nylocks, if you use a power drill or an impact driver, it will spin them and create friction on the nylon as they're doing up, and that will melt the nylon, and so it won't stay, it won't have the lockup feature that it would normally have. They will come loose. So I strongly recommend you use a hand screwdriver to do these up with. Just to prevent that failure from occurring. I found that while you are gentle with these, I mean not going too fast, you can reuse them, but if you use a power tool on it, you will have to replace them every time you use them. Otherwise the nylock will not hold. Now that's firm when rotating it, not overly loose. Not too tight either. That's all good. All right, so that's all together. Now, as I was wiring up this loom, I only had 8 colours to work with in total. So I decided to drop the brown and I forgot the other colour, but I used the black and the red for power. Now I could have the black and red wire here is a silicon wire, and it's actually an 18 gauge wire. The rest of the wires are 24 or 28 gauge, 24 gauge. And I've used 5 colours, which I've repeated for each side. And you'll see the bit of heat shrink here is black. All of the left side all of the right side of R2. All these servos are connected using this side, and the red ones are the left side. And I've actually got them sort of semi-color coded. So this is the yellow wire, this one here is the green, these two here are the orange and white, and this one here is the blue. Coming around this side, we have blue on the red side, we have orange and white for these two. This one for the bread pan door is yellow. Yeah, that's yellow, and the one for the data port is green. So we've got the same colors, and they do very similar functions on each side, but we have got our red and our black. And I've got a little bit of room so I can get that onto our servo outputs. And of course the red and the black are separate, so that'll go to our power supply, because I will need 6 volt for all of those. Although some of those will do higher, the ones up here are only rated at 6 volts. Alright, so what I might do is actually mount one of the legs on. Maybe even both the legs. We'll mount both legs. I'll do the right hand one first. Mostly because it'll be easier to see it on the camera. So these are greebles. I've painted them up, but I haven't glued them on yet. I will do that at some stage. But if I take this horseshoe off and this booster part off, remember they're magnetically connected. I'll rotate all this around so we can get to it, and we might just have to rotate that. Now I have got R2 sitting on a box at the moment just to give it a little bit more height. So those 4 bolts, I've previously mounted or assembled the shoulder hubs, and they've got M8 bolts M8 bolts sticking out this way, and we have these pieces which push in and into the hole and lock it in place. A washer to hold it, make sure it doesn't damage the plastic part, and then we put on our nylock, M8 nylock. $13mm. These ones we can do up reasonably firm. Again, these have got nylocks on them, so I'm doing them by hand. I could use an impact driver, but that would damage the nylon and the nylock. Alright, so we have legs on R2. There is one more leg that we can put on, and that will allow R2 to stand on his own without a box underneath to help support him. So I'll just get all these wires out of the way. Make sure I have the center wheel orientated the right way. I've got this with a stopper on it, so it'll only go so far forward. Pull this box out from under it. And drop this wheel in. Got a couple that are being difficult to get in. I may have to pull them right out and put them back in again, but I will do that off camera, get them lined up properly. I may have some nuts that are not engaged properly, and I can pull them up and then get them to engage. Unfortunately, the nuts are not accessible at this stage of the game. That one is doing up. Well, that's not too bad. I've only got one, maybe two that are giving me grief. I'm not convinced that one's taken up, and this one's not going down far enough to take up, is my thought. Okay, so I think that's as far as I'm going to get for the moment. What I'm going to do now is bring the wheels back on the left and right sides. And R2 is now on his own 3 sets of wheels. There are some locking parts that can drop into the sides over here, and that will prevent these from moving. I might put at least one in each side, and that will allow me to then later on hook up the power for the wheels when I've got the controllers built and drive them around. Well, that'll do for this video. If you like these videos, don't forget to click on like, subscribe, and ring that notification bell so you know when the next video comes out. It's also a form of support that helps the channel a great deal and costs you absolutely nothing. If you'd like to support the channel further, I do have a Patreon account and YouTube membership. There will be links in the bottom, and you can join my VIP patrons GoLucky, Coburnicus and Jeff Jerde, and my builder patrons Almorales45, Andrew Cardone, Airgar69 and James Kelly in helping to support the channel. All my patrons get and YouTube members get these videos a week before the rest of the world does. If you've got any questions, feel free to drop a comment below or drop into the Discord and leave your question there. If I can't answer it, someone else might be able to. And we'll see you in the next video.